Welcome, everybody. Welcome back. We're excited to kick off the last part of the day. Hope everyone's enjoyed your break and looking forward to our final sessions, and they're definitely power-packed. We have a very distinguished group here talking about something that's been talked about all throughout the conference, and that's data centers. And we're fortunate enough to have teams that are working every day in real time facing this issue, building and solving for these challenges here. So we're going to start right here to my right. And Damali, why don't you kick it off and introduce yourself?
Good afternoon, everyone. My name is Damali Harding. I am the U.S. Program Director for the Regulatory Assistance Project. And the Regulatory Assistance Project supports energy decision makers in the clean energy transition. We are a nonpartisan nonprofit that works across all 50 states and several U.S. territories in supporting everything from technical assistance, docket development for commissions. We write a lot of white papers. And one of the key areas of why I'm here is thinking about what is the role of the energy regulator in AI and data centers? What is it that they should be thinking about? In particular, I'm going to mention the T word, which is tariff. When we start thinking about energy centers and data centers, one thing that's really missing from the conversation is what are the rates structure? What does that look like? Is this the time to innovate, right? We don't have a traditional cost of service model. Is that going to be sufficient for what we need in terms of both quickness to plugging in, as well as thinking about unintended consequences of load growth?
John?
Well, good afternoon. Operating 18,000 miles of electric lines, operating thousands of miles of fiber infrastructure, including a fiber to the home system, operating a national IT company that first self-serves our co-op and then is working across a number of states, running a local regional brand focused on energy services for our members and the region, and working with a hyperscale marketing entity. That is what we're doing at Rappahannock Electric Co-op today, working to make sure that we are powering up the portions of 22 Virginia counties and the data center explosion, if you will, that you heard Peter Mahoro speak of earlier in his keynote. So really thrilled to be here with the panel today, Jason. Looking forward to talking about the implications and the impacts of AI in our service region, and certainly the rates and how we're structuring our business.
Thank you. Jim?
Hi, I'm Jim Barber with Enchanted Rock. I lead our efforts to working with our utility partners on the eastern half of the country to bring resilience to the local market, but in this data center space, more importantly, help bring a faster, reliable solution to the 5 to 7 year delay in getting transmission and generation built out to build these data centers.
Roger Kranenburg. I'm with Eversource up in New England, Boston area. I lead strategy, which is looking a little further down the line for the utility. I also play a very key role in the industry, looking at what the industry started calling as resource adequacy and what we've sort of evolved to calling energy security. Because if you look at where the U.S. economy, the global economy, and security, and a lot of things, if you read the Wall Street Journal article, it's much more tied to investment in the electric industry than it has been in the past, which was more tied to oil and gas. I also have the pleasure of leading federal affairs, so I just got off a call talking about budget reconciliation. And if I slip down that path, call me out on that, because this is not the topic for this discussion. And then the other point of note is I'm on the advisory board of a data center company, a modular data center company called FlexNode. So looking at it from that perspective. And that came to me through my former friend of mine from my telecom days. And I sort of cover those areas.
John, I want to jump right into you because I know you guys are dealing with this issue in real time. And so can you catch us up to what are some of the latest developments with REC and what you guys are working on in regards to data center
Absolutely. Thank you for asking. So, Virginia has a long-standing reputation as a epicenter for global computing with respect to data centers. That wave is moving, if you will, out of Northern Virginia to the south and to the west, where land and large parcels are available. Virginia has been, 3 out of the last 5 years, CNBC's top state for business, and one of our biggest challenges is going to be how do we power our success in the future. If you look at the Commonwealth, the last several years, the data center investment has represented 80% or more of the business investment in Virginia. Not necessarily the job percentage at that height, but the actual dollar magnitude investment. So at Rappahannock Electric, we serve, as I mentioned, portions of 22 different counties. Our counties have some differing appetites for data centers, but really the question locally hasn't so much become, are you for and against data centers, but it's more, are you for fire trucks and first responders and EMS and police and sidewalks and parks and rec and those types of things. So some of our counties are extremely enthusiastic about the data center developments, the investments that are happening in their communities. Some of these investments will far and away represent the largest investments to date in history in those counties. And so as the local service provider, it's our job to do it, not just to do it well, but to do it with kind of the surgical precision and the responsiveness that we are known for as an electric utility for some 85, 90 years now. I think what's really, what the real challenge here is how we're structuring our business, and I'll get right to this. We've taken some really unique approaches. The co-op, the traditional co-op, if you will, is owning and maintaining and installing and constructing the substation infrastructure. We have a rate filing today that's being reviewed that basically seeks to bill the data centers at installed capacity, not billing demand, but actually installed capacity. And I'll note that the data centers are prepaying for the installation of these substations, these direct serve substations. The more unique side of what we're doing is really on the energy supply side of the business. We created Hyperscale Energy Services as a for-profit affiliate under REC, if you will. Hyperscale's job is to provide market power, streamlined, efficient market power to PJM, to these large-scale data centers. And I should go one step further to say that Hyperscale Energy Services is our knowledge and operating center, but below that is Hyperscale 1, Hyperscale 2, Hyperscale 3, et cetera, et cetera. HE1, HE2, HE3 will be our PJM off-takers, and that puts each data center customer, not specifically a site, but a customer, as they might exist across our whole service territory. It puts each data center customer in a subsidiary dedicated service affiliate. And that puts us on a standing with them where they will stand on their own credit, their own interest in the market, the types of resources that they might want or not want from a surgical perspective, and our ability to capture the true cost and impacts of serving the data centers and make sure that they are bearing that cost and that we're also getting the job done and getting it done very well. So Jason, just a little bit about how we're structured today and kind of a more unique approach we're taking to serving data centers in the electric co-op space.
And Roger, you kind of got to hear for John and what they're doing there. But to get there, right, we have to solve these tensions between tech companies and data centers there. And how do you see that playing out there for Eversource and some of the things you guys are working with in handling this issue?
So on that one, I'll speak more broadly at what's going on in industry, if you don't mind. And the reason for that is, a lot of the build out, as you're referring to, definitely Northern Virginia, but you're seeing a lot of build out in Louisiana, Georgia, around the country. And the tensions were, or call it tensions, but sort of traditional way of doing business is you'd sort of say, okay, I need about 100 megawatts of load at this location, and you send in your application, and then you would go through the process and then be studied, et cetera. And what we the industry saw over time is, and you've been reading this, it's ramped up to, it started at maybe 10, 20 megawatts, 50, 100, 300, 400, a gigawatt. And the big difference from things in the past of that level is, if you wanted a manufacturing plant, there was kind of a lead time that, that would take to build a manufacturing plant, hire the people, ramp up. And those are much more compressed in the data center world with very, very large loads. I mean, some of these loads exceed cities in some respects. So that's really sort of stressed the traditional way of doing things. And then on the sort of internet connection requests, the way that would get typically processed is you would make sure that 99.99% of the time you can draw that power, and the system would be accommodated. So those are sort of the traditional ways of doing things. You fast forward to this world, and from both perspectives, both the tech companies as well as utility companies, it behooves both of us to accelerate time to power. And that's the big sort of obstacle for the tech companies. That's the big opportunity for the utility companies on behalf of its customer base and on behalf of the economic development and vibrancy of the region. So bridging that gap, there's a lot of more sophisticated conversations starting to happen now in various parts of the country of how do you sort of get to the end objective, but differently than the conversations that's been had in the past. I know the West Coast utilities, there's been some creative thinking there. I'm sure the gentleman from Enchanted Rock will talk about some new developments there. So that's evolving, and part of the evolution that Damali, I think, will talk about some more, is this realization of the traditional customers, let's call them, will not bear the cost and the risks of some of these investments, and that's really, really key in the regulatory sphere. In my sort of day job for my company, what I shared with you is kind of industry overall, a big boom in what I would call sort of learning data centers, these massive, massive data centers. They're not as locationally sensitive outside of the fact everyone wants to be in Northern Virginia because 70% of the world's data traffic travels through there. But outside of that, they're not as locationally sensitive. In my day job, I'm charged with looking a little further down the line. And in that, we're not seeing the big learning data centers in New England. It's too expensive. In that, I'm looking at, okay, learning's great, but why are you teaching all this stuff if eventually you've got to start using it, inference? And so looking down the line of, what does investment look like for inference, both human inference, where, we ask ChatGPT or whatever it is, or interacting with it sort of with human latency acceptance. If it takes half a second to get a response, fine, it's okay. And then even further down the line, when you start having machines pinging these AI models, that becomes a lot more locationally sensitive and sort of thinking through that. And I don't have the answers, by the way. If you have the answers, let me know. But thinking through that sort of future evolution of AI data center stuff.
And Jim, I'll take it back to you to kind of get your chime in there, because you guys are working with this and this concept of these flex load benefits and the things that you guys bring to the table and require us to look at the problem maybe a little differently. Can you expand on the work and maybe share an example of how you're working with either utilities or data center companies to help solve this issue?
Yeah, that's, Roger's had made a couple of points. One, the utilities are worried about resource adequacy, the 5 to 7 year lead time to get infrastructure built from capacity run to a new data center site are all challenges that the utilities have to face. And the hyperscalers, don't want to wait 5 years or more to build these data centers out. Matter of fact, we've heard recently that if they're told by a utility 5 years, they'll walk away. And the utility doesn't want them to walk away. They would like that base load of 1 gigawatt for the next 20 years. So by leveraging the reserve margins or the RA and making that data center part of the grid infrastructure itself, making it a resource, not a liability, you free up what is today reserved for emergency purposes, which is 95% of the time available. And then you bring enough on-site generation that when the utility does need it for an emergency situation or a heat wave or a cold snap in the winter, they dispatch the local generation, take that site offline, export whatever's left over, and serve the grid that way. That allows a few things. One, it does allow the data center to come online quicker. You can use that technology as a bridge model for a year or so while the substations are being built. And then as the additional infrastructure is being built out, you can switch over to the more flexible operations so you're not running 24/7. The other thing it allows is because this flexible capacity is built in a modular configuration. As the load arrives, you add the generation. You're not putting in frame 7 somewhere out in the middle of a service territory, hoping that the data center actually does get to that load. To your point, we don't know what's going to happen in 20 years, and there is a lot of fear of overbuilding. So by using smaller modular solutions, you can grow with the load, but not overburden the rate base with too much infrastructure that will never be sold.
And Damali, you're trying to herd the cats and be a magician with the regulators and the commissions you work with. Like, what are some of those big bottlenecks you see, but also the opportunities on the new structures and the innovation, hopefully, that you're starting to see?
Yeah, I think one of the biggest challenges is that many of the discussions that are initially happening are happening at state legislative energy committees, where people don't have necessary industry experience and they are looking at it from a different perspective. And I think Virginia is actually one of the great examples of where the State Energy Committee said we have to get smarter and better and started calling together experts to talk about all of the infrastructure, not just the load, but what do we do about transmission? What do we do about distribution? How do we think about even ordering now our commission to start looking at what does this do to integrated resource planning? Like, do we need to make both of our IOUs start to think about IRPs, and how do we incorporate these different pieces? And so I think, again, that's one of the biggest challenges. The other challenge is that the commissions aren't necessarily sure when and how they should plug in, right? So traditionally, again, under traditional cost of service, you would have your rate case, and that's where they would kind of intercede. And so they're trying to figure out, okay, if we don't have necessarily we can't tell the utility necessarily to not take on this load or to do that. And so trying to help them determine, based on their state statutes, where are the points that they can intercede. They can either do request for information, they can start to think about, again, we've seen some states take already the lead on saying we're going to create rate structures because we don't want to unburden our traditional customers with the stranded assets question, right? Or if we overbuild, or if we build too much in this area and we really needed it and we can't switch it to industrial use later on. And so what are those questions that that commissions should start asking themselves to take on now, also where they can work in conjunction with those state energy committees, and so that you then have a unified approach. And I think that's the approach, again, Virginia being so successful. I went to your Clean Energy Act Day, right? Being super successful, because otherwise you then wind up having these piecemeals, and you don't want to encourage within a state shopping between IOUs. Right? You don't want them to say, okay, well, you're not listening to us over here, we're going to go over here. You actually want to create a unified approach. And then the IOUs, again, know that their costs are going to be recovered, right? So that they are going to be able to build, and that their costs are going to be recovered. I think the last thing is also thinking about, at the moment of what are the other issues and challenges that we need to fix, right? And so is this an opportunity, if you are prepaying or somebody else is being able to pay for your assets, can you extract value to help support the rest of the challenges that we have, right? AI is not the only load growth issue. So at RAP, we actually started kind of moving away from data centers and just talking about load growth, right? If you think about industrial load growth, that in some levels will trump AI by magnitude, right? If we really start to put on even low to moderate heat load industrial growth. And so if you think about transportation, building electrification, and just general load growth in general, what are the other ways that we can leverage what we need for AI and also creating other opportunities for beneficial electrification?
And John, just because they talked about Virginia a little bit, are you starting to hear from other utilities or seeing other regulators, stakeholders trying to learn from you guys?
Great question. So, kind of reflecting back on this morning, you had Mike and Brian up here, right? Mike was talking about the role that electric co-ops are playing, and leaning forward and solving local and state level and national level issues at the NRE state level. Brian with Holy Cross, one of the most innovative co-ops in the nation, actually one of the most innovative utilities in the nation by far, right? Talking about how they're solving things kind of from a technical and member perspective. And then Peter with the keynote kind of focusing a little bit in closer on Rappahannock and our affiliates. We've been hard at work at this for the last couple of years with respect to what's evolving, right? Our first ambition around hyperscale energy services was to take the energy transaction off of our balance sheet. In other words, what I'm saying is 182,000 member co-op can't possibly backstop the volatility of a financial occurrence in a market for a global data center that is, operating in Virginia. So we have an obligation to serve, and how do we do that while protecting our traditional membership, but also getting the job and getting it done well? So we took that to our state commission. They weren't able to allow that under the law because they felt like the law didn't allow that model. So we went to the General Assembly and the governor signed really what I would call the hyperscale bill. That was our proposal, and that was signed into law this past spring, right? So now Virginia is allowing electric cooperatives to serve large loads over 90 megawatts through for-profit affiliates. And again, Rappahannock Electric, the co-op, is owning and installing the infrastructure in a very traditional way, although it's prepaid. And Hyperscale Energy is our entity that is kind of providing for the energy service. That includes energy kind of out of the gates from in-service on throughout the life of the project, but also includes standing by as a provider of last resort, which is an obligation for the local distribution utility under Virginia code. So we've had to navigate the code carefully. We are getting a lot of questions about what we're doing. And just a quick aside, I shared with our commission, Peter mentioned we have a 20,000 megawatt inbound load ramp, over 4,300 of that is already contracted. Our co-op, we have $1.3 billion on the balance sheet. We've transacted over $800 million in commitments in about the last 18 to 20 months, and we will pass $1 billion in dedicated data center substation infrastructure commitments before the end of this year. So the time will likely come when our data center infrastructure exceeds the balance sheet of the 182,000 and growing member co-op. The energy transactions for hyperscale are likely to exceed the current operating revenue of the electric co-op. So the order of magnitude is relevant here. And I guess what I would say is, when the business changes, change the business, right? That's what we're doing. And I think if you go back to Mike's comments about co-ops and Brian and Peter with respect to kind of their deeper dive on some solutions, this is another way that we're innovating. And I think it's necessary. One last point. If you looked at, and I shared with our commission last summer, if you took a 6,000 megawatt load, I can't really believe I'm even talking about a 6,000 megawatt load, but they're all in the same market when you're transacting as a market sleeve. The weekly clearing for that load in 2021 in PJM would have been about 35 million weekly. And this is about a 70% load factor. The weekly clearing in 2022, when natural gas prices had gone up due to the Russia-Ukraine crisis, that was in the order of 67 million. We took the billing determinants out of Virginia, out of the Dominion zone for the week of Winter Storm Elliott, which was around Christmas Eve in 2023. And that was a $135 million clearing for that event. And I showed our commission one last scenario. We took a Winter Storm Uri and essentially did our best replaying it in PJM, not at a $9,000 cap like LMP, like in ERCOT, but at about a $4,500 cap or $4,400 cap. That was a $700 million weekly clearing. So, this is why the business has to change, why we have to take significant measures to protect the balance sheet, but also establish an environment where the benefits of serving and doing the job well flow up to the co-op.
Jason, I think one of the common themes you're seeing with what Jim and Damali is sharing is it's got to be in harmony with policy, local policy, state policy, and I would make the argument you're getting to a new frontier of national policy. Because if you look at this from a national perspective, it's truly a national security issue. We really don't want a lot of these very high performance data centers to be away from U.S. soil. So policy is a really, really key area. It's got to be in harmony with the policy. In harmony with policy, as Damali knows very well, means what's important to that community, what's important to that state. And every community and state are going to have different importance and requirements. And the point you made about the fire trucks, not everyone is embracing and loves nuclear. The places where there's nuclear power plants, they absolutely love them because, schools, fire trucks, all of that. And to the point you were making, this kind of evolution, we've kind of seen it in different ways in the industry before. I remember the days when combined cycle gas plants came online. The rhetoric was, we provide kilowatt hours, we don't do anything else. Well, it evolved to like, yeah, you're such a big part of the system, you do a little bit more than that. You do generation control, et cetera. Then you had wind come along. And the early days of wind was, we do kilowatt hours, we don't do anything else, until they would go over speed and trip off it instantly, and the system operator's like, whoa, you can't do that. You're part of the system. So you're seeing this kind of natural evolution as these assets become bigger and bigger parts of the system in harmony with all of the policy asks, so to speak.
Jim, you've heard a lot there. I wanted to ask you, what frustrates you when you're talking to utilities about this?
What frustrates me when I'm talking about this? How much longer we have? No, actually, when you start off talking about distributed energy assets in in a small block, and you're talking about a half a gigawatt to a gigawatt worth of load, just the concept of, well, we're a utility, or we're a data center, we're used to buying these big blocks of iron. Well, the frustrating thing to me is that's 5 to 7 year lead time now for a turbine, or 5 to 6 years for a diesel generator, and just not the mindset of, hey, if the business is changing, you got to change the business. So that's been frustrating. It took about 3 years to really get this modular concept into people's head. But when you can show that you can build 150 megawatts of grid-connected power in 14 months, from time of order to time of commissioning, that brings a lot to the market that I think that we haven't seen before, from other assets. So, I think we're getting there. I would like to see the data centers start to think about how they change their model. Every data center brings 120% of their total load to the project with a diesel backup generator behind the meter. The utility can't use it for any kind of peaking power, or when that wind turbine overspeeds and causes havoc on the grid because of environmental issues. And the data center operators are comfortable because for the last 50 years we've been using diesel generators. It works. We don't want to change. But now you have an asset that gets you online faster, can be used by the utility or by the grid operator to balance the load and allow more renewables to come online. So you have the data center already paying $600 million for diesel. So what if they apply that towards this natural gas solution? Now the rate base has an on-site system that has local capacity value or system capacity value that's less than you can buy a turbine for. So it's kind of a win-win if everybody works together. And then you got the regulators in there that kind of put some brakes on some things too. But in a perfect world, I think if we can get to that here in the next several years, or hopefully months, then we can accelerate this AI boom that everybody's talking about, that is a national security issue.
So Jim, I think you're being a little bit delicate. So what's it like to deal with your system planning engineers and your interconnection studies? Come on.
Well, how many of them? No, I'm not going to say that. No, so it's a process, and everybody's now talking about going into cluster studies, and that's going to solve the problem. Well, a cluster study is not going to solve the problem, because a cluster study, as soon as you remove one piece, you have to start over again. And yes, we have to figure out how we're going to affect other systems and what's going to happen. But we do have to figure out, how we take this 5 to 7 year wait and get it down, somewhat manageable. That was bad enough before last year. I had the privilege of working for GE in the early 2000s, and we had the huge gas turbine boom. We built plants, we did all sorts of things to meet that demand. And then the bubble burst in 2001 to 2008, so all those facilities were closed. Well, the turbine manufacturers aren't going to restart those plants for another short-term bubble. So now, not only do we have the long runway for getting everything permitted, but now you've got a 3 to 5 year wait for your turbines too. So, if we're going to get there, we've got to change the way we think.
All right, we'd like to invite some folks up to have some questions and step to the mic. There's been a lot of discussion about this topic. Feel free, or if you want to raise your hand and yell out a question, we're more than welcome to. Oh, HG, come on up.
Good afternoon, everyone. Good to see you all. I was really excited about this topic because I was texting this link to a gentleman running a data center conference right now in Boston. Hey, Roger. That was actually Galen. And the headline is, Elon Musk brought the world's biggest supercomputer to Memphis. Residents say they're choking on the pollution. What do you envision is the ideal standard that we can start to develop for data centers that create the best win-win with community and economic opportunity?
I was going to say, so I can start this. So one of the things we published a lot of white papers, and last year we came out with our 24/7 tariff. And so 24/7 tariff essentially matches hourly instead of annually renewable energy to a tariff rate. And that was work and sponsored by one of the big tech companies. And I think that's a way to, when we start thinking about a lot of the policies, the 5 to 7 years no longer works, right? That has worked in a traditional model. We need to think about what are the ways that we can innovate while still maintaining affordability and defining affordability differently. Affordability doesn't mean that prices are going to go down. Affordability means that prices are going to be affordable in the context of which they're provided, right? And so 24/7 is one tariff and one way to think about that. How do we think about the incentive models, right? So again, one of the biggest concerns we're hearing from regulators is the potential for stranded assets, right? I have an MBA. At some point, there are going to be winners and losers, and so everybody can't win at this game. And so, what happens, and who pays for that, and how do you mitigate that risk for customers? And then thinking about, if we think about the utility business model, and I love this, and I heard this, and I've always kind of kept it. It's never kind of a traditional business model. It's a regulatory business model, right? Like hyperscale is in business because of a regulatory place. And so again, thinking about how do we bring together the state energy commissions, or the state legislature commissions, the public service commissions, and really thinking about what is important to the communities and what is important to, like, where do we place data centers, right? So if nuclear becomes the option and we repurpose, for example, coal plants, which is an idea that a lot of states are looking and analyzing that, how do we do that to make sure that we're not going to have the same cancer alleys and the same things that we had previously, to ensure that those communities are still reaping the benefits from, again, access to energy, and access to affordable energy that they can also then leverage and use.
Yeah, Jason, I'll jump in. I'll just say, and I agree. There's there's a ton of innovation that is occurring, that will occur. From our perspective, we need the data center to equitably pay for its burden. The infrastructure, without any stranded investment, to fulfill their obligations around transmission capacity. In PJM, we have capacity payments, and LMP energy, as volatile as that might be from moment to moment. We need them to provide adequate credit support for us to keep them in the market, and we need them to provide emergency liquidity in the event of a market credit call. So that's kind of the business side of this. From an infrastructure perspective, we need to make sure that public utilities and others are not impacted from corridor transmission uplifts, where a non-data center substation might be impacted by a voltage uplift on a transmission corridor. We need to watch out for that and not have a transfer of obligations to different ratepayers under that. And then certainly, I believe we're going to need some data center adjacent capacity resources, generation on-site or adjacent in the load zone. One of the issues in Virginia right now, as it works to contend with its positioning of its Clean Economy Act with a tremendous load ramp underway, is leaning on adjacent states. And so we've got a lot of transmission infrastructure going into the rate base that's going to be with us for decades to come. That is really Virginia's solution right now to get to permissive states that are allowing new generation of different resources. We're going to have some energy in the load zone. I've met with a lot of our lawmakers to just explain, and when you start getting into, those are really much deeper conversations than we might normally get into legislatively, but you've got to have an understanding of how the market works to understand that the cost of energy delivered in the load zone is very different when it's derived out of state once you net it up with congestion and losses. So there are a lot of complex topics. I'm excited about the wave of innovations that will occur in our industry as a result of this.
So I think part of the genesis of your question, HG, is impact on the community. We talked about impact on the electrical system. They're bigger and bigger parts of the system. They're a more integral part of the system. I think the question you're raising, if I understood it correctly, is the impact on the community and the acceptance of the community and what the community values. So I think you mentioned emissions in the local community. It's a balance because they want the new fire trucks. They want the new jobs. They want the new economic development. Nobody wants increased emissions in their area. And part of that dynamic is also noise. I know a lot of folks that live in Loudoun County, and they're not crazy about the constant buzz of data centers. They like all the positive stuff. And it's a little bit like what utilities are kind of, you can think of them instruments of public policy. Like, we do what's right for public policy to be successful. And part of that, and we've learned sometimes the hard way, is engaging early and often with the community and teasing out what's really important to the community and the trade-offs and balances. And that's an area maybe where utilities can help tech companies a little bit and sort of engaging early and often with the community in developing these what's much more impactful projects than small data centers stuck in an office building somewhere. And some of the maybe future ideas could be data centers kick off a lot of heat, even in the winter and the summer, et cetera. But so maybe in another parts of the country, maybe they can become a source of heat for the community. You can heat a school, or you can heat a community center or an emergency center. More integrate them into the community using a geothermal loop or something. Again, back to that innovation and thinking a little bit further down the line, starting from the point of engaging early and often with the community and teasing out what's important to that community, and not using sort of broad brushes approaches of everyone likes this, but engaging very directly with that community. And I'll give you an example of a success story for us. We put in a battery in Provincetown. It's 38 megawatt hours, 24.9 megawatts, and the power people can appreciate why. It's a pretty impactful facility, but we engage with the community. And typically, the communities will fight us on substations. This community absolutely loves this project. They're a huge fan of it. It looks like a glorified substation, but the community is super excited about it because of the early and often engagement on it. And then we've got projects on the other end of the spectrum where we didn't do that, and it hasn't gone as well, and it also takes forever if you don't do it well.
And just to go back to the Elon Musk thing, that did happen because of the delay in getting power to the site. So the only way that Elon could open up his data center was to bring his own power to site and put those turbines in, which, by the way, he didn't do with permits. But as you look at this data center growth, if the utilities and the regulators don't figure this out, and we don't help figure it out for them, then we're going to have more of those situations where the data center is actually building their own power plant. And it's there's much more cleaner, affordable ways to do this to make sure that the cleanest place we buy are 99% of our power is from the grid. That's the way we get to having clean air in this country. But to have localized, flexible generation, you don't put as much pollutants on the people in the community. They don't have that noise all the time. They're only seeing a couple 100 hours a year, and then you're flexing the load back and forth from there. And I, yes, I'm
We still have 5 minutes. So someone want to get another question? Thank you.
Howdy, Jim, Damali, it's Andrew Higgins with KPMG. And the question is regarding the future of utilities and data centers. So right now, the grid operates like it always has. And you have these huge loads that are now, like we've never seen this type of load before. And when those loads go offline or something bad happens, the balancing authorities may or may not be able to deal with it. Now, we saw this in Virginia last summer, and we recently saw it in Spain. What do you think is the future of grid technology and innovation that will be able to deal with the uncertainty and instability that those assets bring to the grid?
I'll jump in. In addition to kind of that, I would say, regulated adjacent capacity resource and some careful use of those already being installed behind the meter resources, right? They're there. They need to be utilized to a certain extent where we can find a business model to do that. But I think the other thing that we've got to have tons of energy storage, right? We're going to have resources that can quickly respond to a much more dynamic environment. And that's load coming on and load going off, and gensets coming on and gensets going off, and a much more dynamic energy pricing. And we've chased capacity for years, but I think we're going to see the point where we're going to be chasing energy, and energy arbitrage is going to become a much bigger economic play than it is right now across most of the structured markets.
So my take on that is my money is on the engineers on that one. The engineers do an amazing job of keeping the system going and balanced. And if you talk to them, what they do is it seems miraculous, but that's their single-minded focus, is keeping the system up. I have a lot of faith in new technology is going to be one of the tools that's managed. So part of my background is control engineering, and very, very high performance controls that can react very rapidly to something like a falling line. It's like catching a falling knife. In prior technology, it was almost impossible. But you look at sort of some of the new technology coming online, including the latency of 5G, you can do some pretty amazing stuff all the way to the edge. So I think that's going to be part of it. But overall, it's more the culture of the engineers of that's their meaning of life, is to keep that system up at all costs. So you've had some pretty dramatic events happen, and engineers have kept the system up. I mean, some of the ones that you trip a nuke off a system, that's a shock. That's 1 gigawatt dropping off the system. That has a big impact on the system. It's one of the events in Texas in the early days of wind. Everyone said, oh, you put too much wind on the system's going to collapse. The engineers caught the system. There was a big front that passed through, and it went from full-on generation, dropped to 0, and then full-on generation again as the front passed over. The engineers, it was hairy from what I heard, but the engineers kept the system up. So my money is on the engineers and giving them the tools and the requirements to keep the system up, and I think they will do it. But it's not. There's going to be some mistakes along the way. But again, my money's on the system engineers to keep the system up.
And I think unironically, AI is the solution, right? So there's some companies that are starting to work within utilities, so not just thinking about the data center that we are using to generate, answer questions, but within utilities and within to think about how can we look at the system differently, how can we leverage that, and so how can you use AI as a partner within that? Also to your question, Andrew, thinking specifically about the distribution system. So we at RAP have spent a lot of time over the last few years thinking about transmission. We are now kind of refocusing to think about, okay, what does that look like at the last mile? What does that look like at the points of interconnection? So we've been talking a lot about battery systems. And again, that's an incomplete regulatory framework, right? Do not ask, if you want to hear me go off, ask me about BESS. But it's such a necessary framework to think about How can we leverage, like, what happens if I want to put in a battery now? And then also thinking lastly about even if everything else were equal, we are still dealing with volatile weather patterns. We are still dealing with, utility infrastructure that on a normal, like your transformers would have lasted X number of years, that is now shrinking. And we are dealing with global supply chains for even the most basic infrastructure needs where, again, if it used to be 12 months, it's now 24, 48 months. And so all of these things are converging at the time of where we're trying to hyperscale. I'm sorry to borrow that, but at the time we're trying to hyperscale. And so it's not just a policy issue, it's a policy issue that is much more encompassing than what it has traditionally been in the past.
And John, I'll let you close it out here. You've heard a lot, and what's your recommendation for the audience to go out there and do and contemplate to help us empower the AI revolution?
Well, first of all, Jason, thank you for putting on this entire event. This is a phenomenal venue. There's been just unbelievable conversations already here at ETS. I would kind of say, look at what we were able to do in Virginia with our legislature. State commissions, lawmakers are desperate for solutions. These topics are extremely complex. We may have to go to a greater depth of discussion with lawmakers and policymakers than we've ever gone to before. But I would say this, bring your solution and push it, right? Bring your solution and work with your regulator and your lawmakers and your state licensing regulatory agencies. Push your idea. This is a time where a good idea can get a lot of traction, and there's not going to be a perfect idea. We are going to make some mistakes along the way, and take your ideas and run with them, and that's what we've been doing at Rappahannock Electric.
And we can help you translate that into their speak because they don't hear it the way that, that they do.
Yeah. 2-hour discussions getting into congestion pricing. That gets a little that's a little much, but that's where we're at, right? When you have to understand the market a bit.
All right, well, we'll end with good ideas and get a lot of traction at this time. Panelists, Damali, John, Jim, Roger, we really appreciate you guys coming into ETS and sharing with the audience. And thank you so much for the panel.
Thank you.
Thanks.
Now I'd like to have the pleasure of introducing Joyce Dooley, who will be moderating our final session of the day. And it's a great one.